Hi, I want to take a moment and talk about Kanban as one of the tools that a company that engages in lean systems thinking would typically use. Now, Kanban, like a lot of what we do in lean thinking, stems from a Japanese word where Kanban refers to a card or a visible record. And a Kanban is typically used to try and reduce the amount of work in process inventory. Okay. Most of lean thinking focuses on reducing inventory to as little as possible. And having a Kanban is one way in which a company could actually reduce the amount of work in process inventory. Okay. Now, an example of how a Kanban would work would be um, what you see here on your screen, where we have two different departments here. One is a fabrication cell, and the fabrication cell puts together parts of raw materials that the assembly line requires. Okay. And a company would have a number of options. One could be, what if the fabrication cell made a whole bunch of stuff, put it in inventory, and just have the assembly line go and pick it up from a warehouse somewhere whenever they needed it. Okay. Now the problem is that you're going to have a bunch of inventory sitting in a warehouse. Inventory is a cost to the company. So the more we have inventory sitting in the warehouse, the more we have a cost to the company. Okay. Now, the Kanban approach says rather than having inventory sitting in a warehouse somewhere just waiting to be pulled, what if the assembly line used, say, what's called a two-bin system, where they'd have two containers of parts at any given time, and they would start off working, say, at 8 o'clock in the morning with one bin. Okay. And if you look at the illustration here, you have the two bins filled with parts. Okay. So the assembly line here will pull the first bin at any given time, work on that first bin, and when they're done with that first bin, they would move that bin over to the empty container section, and that becomes your Kanban signal. It becomes a signal to the fabrication cell that the assembly line will at some point in the near future require additional raw material supplies. Okay, so your visual cue here, your Kanban, your card here becomes that container. An empty container becomes your cue that there's a need for additional parts. Okay, so at any given time, the fabrication cell is only making one container at a time. So while the assembly line is working on the second container, the fabrication cell is working on the third container. Okay, and as soon as they're done fabricating the third container, it'll move to the full container section, waiting for the assembly line to finish work on the second container. Okay. So the beauty of this is that at the end of the day, you don't end up with a whole bunch of parts of spare of raw material parts that have not yet been put into production because you didn't have a system in place to reduce the amount of work in process inventory. Okay. So that's how the Kanban system works. Its main focus is on how do we reduce the amount of work in process inventory. Okay. Now let's look at an example. And this example here is going to be looking at how do we calculate the work in process inventory? How much parts do you typically have at any given time? Okay. And for Kanban calculations here, they're very basic calculations, and they're basically going to be focused on typically figuring out for any given workday, how many units should we have in each container, or even how many containers will get us through a workday. Okay. So we are going to be looking at figuring out this our work in process, our WIP. What's our work in process at any given time? Okay. Now, if you look at the work in process calculation, it's going to be a function of what's the average demand rate for the day. Okay. And if you look at the formulas that we have here, the first formula that we have here, let me pull out my pencil. The first formula we have here, WIP equals to KC. That basically says that the work in process is a function of the number of containers, K, multiplied by the number of parts in each container. Okay, so if I know how many containers we have that we're going to need to get us through the workday, we know how many parts in each container, it'll give us an estimate of what the work in process would be. Okay, now if you take this a step further and figure out what exactly goes into this calculation of what is KC, then you find that the number of total parts of work in process is a function of what's average daily demand, D bar. Okay, D bar, small letter d here is the average daily demand. Okay, If it's a capital D, that'll be annual demand. But that's a different chapter. We'll get to that when we get to inventory management. Okay. But just keep in mind here, we're looking at here, what's the average demand rate? You're going to multiply that by some timing. How much time does each container spend waiting? How much does each time spend in processing? Okay. So if I know the combination of uh, the average daily demand and the total amount of time spent in both waiting and processing, I can have a rough idea of what our work in process would be. Okay. Now, the last part of this formula here, the 1 plus alpha, gives us our safety stock policy variable. Basically, how much safety stock does a company want to have? If the company has very stable demand, there's very little fluctuations in demand, our safety stock policy could be very close to zero. We might not need safety stock, right? So if our customers order 100 units every single day, we know it's constantly around 100, we might not need to have safety stock, okay? But if it fluctuates from day to day, 100 today, 120 tomorrow, 130 the other day, we might need to have some extra inventory as safety stock inventory, okay? So that's where we would add our 1 plus alpha, okay? So then that leads to uh, us having uh, a formula here that we can use to figure out what's our total work in process going to be, okay? Some variants to this question, the type of question you'd experience here would be how many containers would a given plant or factory need to get them through a given workday, okay? And that'll be what I have down here. Okay, here's the number of containers required um, to be able to accomplish a certain amount of output, okay? So for the most part, everything that we have here stems from our original formula for the work in process inventory, okay? And so we're going to look at a example of what are the types of questions that you might encounter with regards to Kanban. And let me remove my pencil here. And let's look at this sample question here. The Westerville Auto Parts Company produces rocker arm assemblies. A container of parts spends 0.02 days in processing, 0.08 days in material handling and waiting. Daily demand for the part is 2,000 units. Okay, so we have our average D, small letter D as 2,000. Our small letter P bar is 0.02, and a small letter W bar is 0.08. Okay, so let me do this on a spreadsheet. You could do it on paper, but let me use my spreadsheet as my paper. Okay, so let's look at the information that's provided to us. I have information on daily expected demand. I have information on, let me reorder this. Let me cut this out. And let me put it down here. Okay, so let's just focus on just these first three parts right here. Okay, and I want to answer the question of what's our work in process for any given day. Okay, and keep in mind, work in process is a function of the number of containers that needs to be used multiplied by the number of parts in each container. Okay, so for me to figure out my work in process here, I would need to know what's the average daily demand. Let me make this just a little bit bigger. My daily demand here, small letter D, that doesn't look so small, so there's something wrong with what I have here. Okay, my daily demand is given as 2,000. Okay, and why is this not visible? Let's try it again. Something's hiding my information here. Okay, that's interesting. An interesting problem to have. I don't see my data. I do see my data there. All right, let me try one more time. Okay, so my data is now visible. Okay, so I want to use this formulation right here to figure out what's my work in process, right? So my work in process is a function of the average daily demand, which is 2,000. and I'm going to multiply that by the total amount of time that each container spends waiting to be processed, which is 0.08, I believe, from the question. And I'm going to add to that the amount of time, no, that's the amount of time spent waiting. And the amount of time spent processing from the question was 0.02. Okay. And that gives me a value of my work in process value is 200. Okay. Now, if I look at my formula here, what I've done is just basically multiplied the average demand by the total amount of wait and processing time. Okay. I've not yet added the safety stock. Okay. Now, depending again on the amount of variation in demand, I might want to add safety stock. Okay. And that's going to be our alpha here. Each production manager has to determine what level of safety stock is necessary to ensure that demand is met. Okay. In the case of our question here, we were told that safety stock is 10% of the work in process, right? So we're told here safety stock equivalent is equivalent to 10% of inventory. Okay. So our inventory amount, our work in process inventory is 200. So 10% of 200 gives us our safety stock. Okay. So now we have 200 as our amount of our typical work in process inventory. And then we have our safety stock at 20. So if I combine these two, 200 plus the safety stock, we end up with our true value of our what's called our work in process, which for this company is going to be 220. Okay. So again, all I just did is try and use the second formulation we have here. Get the average demand value multiplied by the total amount of time required to process that, and then add to that or multiply that by whatever safety stock variable that you're provided with. Okay, so now I know that we have on average approximately 220 units of work in process inventory. Okay, now let's go back to the question we had here. And A says if each container contains 22 parts, how many containers should be authorized? Okay, how many containers? Our container value here is the letter K. Okay, if you go back here, we're going to be solving for K. Okay, and I could use the formulation down here where we solve for K in our formula here. Okay, basically using the value down here. But if I already have my work in process amount and I know how many parts are in each container, then I can get my value of K by dividing work in process by the number of parts in each container. Okay, so my next question, which is asking us what's the value of K, small letter K, the number of parts, number of containers on the number of Kanbans would equal the total work in process divided by the number of parts in each container. Okay, so for this business here, we are going to need approximately 10 containers to get us through all the demand that we need to make. Okay, another question that could arise could be figure out the number of parts in the container. Okay, and it all comes back down to the second formula here. If you ask for the number of parts in the container, it'll simply mean solve for C. Okay, could get a question asking you solve for the average demand if you're provided with all the other parameters here. Again, it'll require you to figure out how do you solve for D. Okay, or if you're told to solve for alpha, look at the formulation, try and figure out how do you solve for alpha. Okay, so that's that. Let me give one more example and then I'll end this video. Okay. And this spreadsheet here is on Folio. So if you go into module 2, you should be able to see this Kanban spreadsheet. Okay. The Edward Jones Toy Company uses a Kanban system to make plastic wheels that are components of several toys. The waiting time, and I think let me do this as I'm getting this information. I'm just going to add it to a table down here. Okay. The wait time that I am given here is 0.25 days. And the processing time is given as 0.15 days per container. Okay. What else are we told there? Each container holds 200 wheels. So C, uh, number of parts in each container. That's given the letter C is 200. And the question here said, okay, we're told again the company uses 2,000 wheels. So that's kind of like our daily demand value. Daily demand equals 2,000 wheels. Okay. And with this, what's the question we're told here? The first question is use the information above and using a policy variable, which is our safety stock. Safety stock is 5% of inventory. And we're told calculate the number of Kanban containers. So the question here is the number of containers needed, which is our little letter K. Okay, so that's what we're going to try and solve for here. Let me make this slightly bigger. Okay, so let's go ahead and solve for K. Okay, again, using the formulation for figuring out the working process, I know that K is a function of our working process divided by the number of parts in each container. Okay, so K here is going to equal the average daily demand, which is 2,000. I'm going to multiply that by the total amount of weight plus processing time. And then I'm going to, again, multiply all this. I'm going to add our safety stock. Okay. And our safety stock is 5%. So that's going to be 1 plus 5%. Okay. And the final step is to divide all this by the number of parts in each container, which is 200. And that then gives us a value of what our value of K will be, which in this case, we're going to need approximately 4.2 containers. Okay. So that then becomes the answer to the first question here. And if I look at the options here, I see 405, 506. I would say this should be the correct solution because if I get a decimal point here, I will be going 5 containers. Okay, I'll round it up to say 5 containers are needed to get through the workday. Okay. See option 2, option C says 506. So that's kind of like confusing because if you have 405 and then you have 506, this answer could almost be right. But I would go with 405 containers here. Okay. Now the next question here says, using the information above, how many Kanban containers would be required if a 10% policy variable is used instead? So if instead of 5%, if we switched to 10%, and the beauty of using a spreadsheet template is that all I would have to do is change this and change this to 10%. We would still need between 4 or 5 containers. Okay. And that's basically how we'd go about figuring how many containers are needed to get us through the workday. Okay. So I just thought to share this. I hope it adds value to what you're going to be doing over the course of your homework assignment or a quiz or a test if I was to give anyone a test similar to this here. Okay. All right. I'll stop here and I should see you guys in class at some time soon.